Hello and welcome to a Code Learn Make video. Today with my friend Freddie, we're going to be programming in C++ from no knowledge to some basic skills. Say hello.
Hello.
Hello. Yeah, you're coming through your recording.
Good.
So you're in your blank C++ project
Yeah.
right now, and if you share screen, Freddie, so I can see what you're coding. The reason I have Freddie here is because it's quite useful to see where errors might come up. Above all, because if you're doing this in Visual Studio, it's a little bit funny. So, yes, I can see what you're doing now. So, the first thing that we need to sort out is the preprocessor directives. And these are the hashtag include statements at the top of the code. And if you're not coding in Visual Studio, you will not have this hashtag include std afax.h. You will not have that, so don't worry about it. If you're coding in Visual Studio, don't delete it, you need it. Underneath that, okay, I want you to type, and I'll type it out, I'll just delete this code and type it out with you. I want you to type hashtag include IOStream in angle, but the IOStream's in angle brackets. And this is telling the computer that we need to include the IOStream set of functions, and that gives us that gives us all the input and output functionality of C++. So stuff like cout, cin, etc. And this is really fundamental, and there's very few projects where you won't be including the IO stream. Next, we're going to type using namespace std, and make sure you end that line with a semicolon. So all your processor directives don't need to be ended with a semicolon. However, every other line pretty much does, with the exception being lines with curly braces. It's a nice way to think about it. So this could be written as this. So if the line has a curly brace, starting or ending, generally it won't have a semicolon. But you'll kind of get used to this. So, for example, for this line of an if statement won't have a semicolon, the line of a function won't have a semicolon, etc. Next, we type in int main, and what this is the code that's actually executed when you run it. So this is where you type all of your print statements, all of your function calls, all of your object initializers later on. This is the really fundamental part of your project. And then I want you to type cout, and then two less than signs. I'm not sure if it's less than or greater than. You know what I mean? Two kind of, angle brackets, open angle brackets.
I'm pretty sure it is less.
Yeah, I think it's less than. Two open angle brackets, and then type hello world, and then end line. And now return 0. The reason we have to return 0, I'll get onto a bit later, and I'll walk you through in more detail this code once you've run it. So now go, if you're in Visual Studio, other IDEs and text editors will be different. If you're using just command prompt and you've installed the GCC compiler, which I presume you have, you can type in C++ and the selected file, for example, C++ hello world.cpp. I obviously haven't got that, and it will compile a .exe assuming there are no errors, and you can run that .exe. On Mac, it's a bit weird, and honestly, C++ is a little bit funny on Mac. Probably best to do it in Xcode, but I'm not an expert. I Google how to code C++ in a Mac and learn from there. But I imagine most of you will be doing it in Visual Studio. So to run a project, you go debug, start without debugging, and then you see we have hello world output to the screen. Okay. Now in more detail, what this code does is we include the preprocessor directives. So the including IO string includes all the input-output functionality, and the include std_fax.h, which is some stuff for Visual Studio. And the reason IO stream is in angle brackets and std_fax.h is just in quotation mark. speech marks is because stdfax.h is not a default function in C++, and it's actually defined. We can see the code behind it, or parts of the code behind it here, so if this wasn't defined, it wouldn't exist. So unless you have these files, it just wouldn't run, and it would say we can't find that file, and your code or it would be a disaster. So if you're not in Visual Studio, don't include the stdfax.h, it will break your code. And unless you have created the header files that associate with the appropriate name, and the header files we'll get onto another tutorial, but they're to do with objects. That's a little bit complicated. But basically, unless you've created them yourself, make sure you don't include any imports in quotation, or including preprocessor directives that are in quotation marks. It will mess your code up. But all the ones in angle brackets are completely fine to include. Next, we use the namespace std. This is optional, and you'll see the alternative in a minute. But what this means is that when we're using certain functions like cout and endline and cin, which we'll use in a little bit, you don't have to specify there the namespace that function comes from. There might be times where you don't want to include this. For example, I was watching a video the other day actually about including the namespace std, and they were commenting that when they worked at EA, they like to they create a similar namespace that replaces std. So for them, obviously, it makes sense that they want to specify exactly where it comes from. And if you don't want to include the namespace std, you have to type in, or any namespace, you type in the name of the namespace and then 2 colons, and it will work exactly the same, and you can remove this line of code. But I think for most people it's worth it because it makes your code more readable, and above all for a namespace that you're using as much as std, it's really important. Next is cout functionality, output hello world. I'll notice we have the output stream function. I know this is getting quite in depth, but it's important that we get some of the fundamentals. And the string, and then another output stream function where we can put another string if we want. And then another output stream operator. And then at the end, you notice we have end line, and end line just starts a new line. And it's another thing in the name, and it's another thing in the std namespace. And then we return 0 because all integer functions have to return a 0. You don't have to worry about. We'll go into that in more detail when we start writing functions. But in a nutshell, you specify the data type that you want the function to return. In this case, it's integer, so a whole number. Therefore, in order for the code to really work properly, you can remove it, but it's not a good idea to. You will have to return that data type. In this case, it's an integer. So that is the code written. Now we're going to talk about defining variables. So as we just talked about, there are data types. Freddie, what data types do you know?
Am I right to say string? I'm retarded.
In C++, that's a little bit funny, because the string data type is not native. But we do have characters, so character X, and they always have to be surrounded in single quotation marks, and then we can put A. That makes no sense. Character X equals A. What other data types are there?
Integer.
Integer, so yes, that's int, and we can do int I equals 5. Then there's floats, which are decimal numbers.
Yeah.
So 7.4.2. Float f equals 4.2. I'll change this to c, so it makes mildly more sense. Int, so char character c. Characters are just c. And I'm trying to think of some more. There's booleans, which can be either true or false. And I think then you have some ones like long and short and byte, but these are the ones that you'll be using most commonly. There's some cool things about that are worth noting, and when you start seeing data types like byte, it starts to make certain things or as they are in code, and why certain numbers are used. for example, in Minecraft, the reason that there's 64 stacks is the largest number you can display with a byte data type, I think 64. So it's clearly storing your item numbers in bytes, which is it's just something worth noting. And I thought about it the other day when I was doing some Java, but it's pretty cool. And once you learn more about data types, you start seeing why things are certain ways. So all of these are variables. And you'll notice that to define a variable, you have the type, so the data type, which so if it's a character, it will be char. If it's a whole number, it will be int. If it's a decimal, it will be float. And if it's a boolean, so true or false, it will be bool. And then you also have what was I forgot what I was going to say. What was I going to say, Freddie? I've forgotten.
I don't know.
His fuck knows. It's all gone. But and then you have the variable name, so whatever you want to call it, and then you can either have so you can either just put a semicolon there, and that's currently has no value, and then you can go and assign it a value at a later point. For example, c equals c. Or you can assign it there when you initialize it, like we've done there. If you're when you if you've already initialized it, so we've initialized the character variable c here, we then don't need to put character because c is already associated with the character data type, if that makes sense. Most of the time in C++, when it gets to more complex products, you're probably going to just be initializing it and then assigning it later in the code. You can also print or output data types. So, Freddie, how do you think we output data types or output variables even?
So you write COUT,
Cout, yeah.
Then you got 2 less than.
Yeah. We call them output stream operators in
Okay, output stream operators.
or output stream operator. Yeah.
And then would you just put in the type?
Just the name.
Yeah, just the name, like
So
I.
and then
just
end line. And then yeah, but another another
oh, yeah.
output stream operator. Let's run this and see how it runs. So debug, start without debugging. So as you can see, we output C. Okay, so once we've covered variables, now I want to talk about getting user input. So getting user input is something that you're going to be doing a lot, above all in C++, where I strongly imagine the vast majority of applications you write will be console applications, because GUI if you want to develop GUIs, I said user interfaces, learn Java, learn Python, learn JavaScript. C++ probably isn't the best language. It's generally much lower level and using operating systems and stuff like that. Not operating systems, but like low level applications, but not really great for GUI development. So to get an input, we type in the variable name. So int x, for example. Notice it's uninitialized, okay? And this means this is just good. It saves memory. We can initialize it and then just change it. But let's keep it uninitialized. It's just good practice because we don't actually care or need that initial value. Now we type in cin, and then it's the input stream operator, and then the variable that we want that data to go to. That looks a bit complicated, but basically what this means is, okay, so when it sees cin, it should say, okay, I'm going to wait for whatever you type in on the line. Then when you press enter, I'm going to assign that to the variable x, or whatever variable it's after the input stream operator, which is this. So when we run the code now, if we debug, start without debugging, you can see that we can input, we can get something, a 5, and you won't see the value, but if we just go cout, the value is colon, and now we can put the variable there. Then we can put endline. So remember, to separate different strings and variables, we can just put another output stream operator when we're outputting out. Okay, so now let's Start without debugging, and see what we get. We can see whatever we put in, so 706,646, and the value is 146. Okay, that's pretty cool. And if you want to have a prompt, we just type in cout, enter a value for x. But notice we don't use an end line here because we want it to all appear on the same line. Does that make sense? Does it make sense, did you say?
Yeah, it makes
Yeah.
sense.
So end line is just like starting a new line, basically. Now if you run the code and enter a value for x, so it's 53. The value is 53. God, I got a sore throat. So this is going fairly well with the coding now. So this is like all of your really basic stuff set up now. So now I'm going to be talking about if statements. So you may remember that we talked about the Boolean earlier on, which is either true or false. An if statement, you put a Boolean. So for example, you put a Boolean expression in brackets, and then anything that you want to execute if that expression is true in the curly braces. For example, if true, cout true. And now if we run this code, debug, start without debugging, we see true. But if you change it to false, it doesn't run. So syntax is fairly self-explanatory. It's not particularly difficult syntax. And now it doesn't run. Nothing's printed because it's false. We can also put expressions or variables. For example, we can have a Boolean will it run. You notice I'm using camel casing, which is where you start each a new word with a capital letter. You can also use underscores to separate them, but the key thing is variable names have to be one. They can't have spaces, basically. Now set this to true. Now we can put in these expressions. I saw someone today actually, and this was a bit of an OCD thing, but they put equals true. You, for God's sake, do not write equals true. Just put the variable. If it's a Boolean variable, you don't need equals true. It will run. Just look. True. It prints true. It's a lot cleaner, and it saves you tons of time. It just makes your code easier to read. We can also have Boolean expressions here. So in C++, okay, some expressions can evaluate to true, and this is fairly self-explanatory. What you have to think is, okay, is whatever statement I'm passing into the function true? For example, and this is where basic. This is the same as, is 6 greater than 7? Let's think. No. So if we run naturally, this will be false. Nothing will print. However, if we put is 8 greater than 7, naturally it's true because it'll print. Instead of just writing 8 and 7 here, we can use variables instead. For example, we can have int x equals 8, 9, and int y equals 10. And we can also use equals, so x, and notice it's double equals. In every coding language I can think of, single equals means assignment, double equals means equals. So whenever you're comparing, use double equals. So an if statement always double equals to say equals. So x equals y. Does 9 equal 10? No. So, naturally, it won't run. However, if we set this equal to 9, it will run. And I reckon that is enough, probably, for this video. It's gone on for quite a long time. So I'm probably going to stop recording here. So thanks for watching, and thanks Freddie for being here, and I'll see you next time. Yeah, so see you guys. We'll have another video coming out soon.